Okay, so there it is for the last video of the path importation section. So in this one here, we will cover NC file. So real quick, for those who may not know, NC stands for numerical command. So it's the kind of file that you need to send to a CNC generally. So it's either a machining or cutting path generally, but it can also be a 3D printing path, as they kind of use the same uh, model of program in the background or way of writing down the program for those applications. So this kind of file can either be generated from a CAM system, so CAM for computer aided manufacturing, so machining software. So you can think about, let's say, Mastercam, AlphaCam, PowerMill, Katia do some, Fusion do some, etc. And in terms of 3D printing, the NC file is generated by a slicer. So the slicer is what will take your part as an object. Let's say a cube, and it will take the cube and split it in slices that are just squares that you will print one on top of the other. That's the concept of 3D printing. So you're printing one layer, another layer, another layer. So the slicer will take that shape you have, slice it in slices, and you will print slice by slice, and the slicer will create a G code, an NC program, and bring it to RoboDK. So talking about that first, RoboDK accepts a certain variety of NC file. We accept .nc, which is kind of generic. We accept .g code, which is kind of generic. We accept .nci, which is the format coming from Mastercam. We accept and we do like and prefer APT file. If you can have APT file generated, those are quite generic and work well with RoboDK. We accept TAP. There's another XLS. No, this is Excel. AXL that I saw at some point that was working fine too. I might be wrong with the actual name of the file on this one, but the concept is that there's a few type of files that RoboDK accepts, but if you can find a post-processor that do generate APT and sometimes just generic APT, that should work very well. So before actually bringing in any NC file, I'm not going to cover, let's say, the robot machining project in detail, because this is how it's called. I'm really here to talk about how to import and what you should look for in your program. But in the next section, we will cover exactly how to use that the file that you imported, the NC file you imported, for either robot machining project or for 3D printing project, for both. So let's just bring a small example here of what a robot machining project can look like if you are bringing in all the all the NC files, so all the milling, or in this case cutting files. So if I start this program here, so this was one G code, or one NC file. In fact, RoboDK, I'm going to show you why later, but created out of that a bunch of smaller program. All of those are what we call robot machining project here. As you may have realized, they are pretty similar to what you would find in a curve photo project. So the only major difference is that you don't have any speed here on top. So there was like automatically approach and retract each curve. There was the curve joint tolerance, and there was the speed here. Those aren't there because it's all taken care of. Anyway, by the actual NC file. So the CAM software will give you those speed information, because those can be very and same for the 3D printing. So the slicer will give you that speed information. It should, in at least, because that speed is directly related to how fast the spindle needs to speed, the diameter of the spindle, and there's a lot of parameters that come in that are dealt with by the CAM software, and we don't deal with in RoboDK. We're just kind of taking the information from one side and then shooting it to the robot, like converting it or translating it to something that is usable for the robot controller. But apart from that, everything is pretty similar. The only other difference you guys will see is instead of having select curve here, you will have select NC file. So in this case here, it created 6 different subprogram, one for each tool path, and it created one main that simply calls all of those tool paths one after the other. So I can potentially here come in and housing in grid, make that invisible so that we can move the other way around here and look at the path and look at it. So the cool thing with NC files is that CAM software, this is their job, so they're good at creating like path like that, profile like that, and you can see that the points are pretty much always like equally distanced, and if you have like a more specific curve to follow, the density of point will increase in certain places like that. Here it will follow the corner. We'll make sure that, we'll make sure that the radius of the tool is considered in how the pad is built. So instead of having, so if you were to just go ahead and select the edge here with RoboDK extraction feature, you would have a pad that would follow the edge, but like the spinning tool would be, like the center axis of the spinning tool would be directly on the edge, which is not what we're looking for. Here, that's a good, let's say, here that's just spot passing in front of us. Here I'm gonna hide tool frame, just so that we can just see the actual tool. So you can see that we have like this offset everywhere that makes the actual blade or cutting side of the cutting tool barely touching the surface of the part. So that's something that we can kind of do with RoboDK. I'm going to show you that later. It's a new feature that's really hidden right now. You really need to have like a kind of cheat code to be able to access this one. But it's limited and you won't ever have like such a good result. So if we can avoid using CAM package with RoboDK, we try to do so because CAM package are quite expensive, but if you have access to a CAM package, that will make your workflow very, very streamlined. So I'm going to show you exactly how you can take an NC file from somewhere that you generated and then bring it to RoboDK to give you kind of a result like that. So we'll go for things that are way simpler than this one for the training. But yeah, that's the kind of result you can expect and try to mimic with the NC file. So let's go back to, I'm just going to close this one here. Let's go back to this one here. You have 11D NC file contour cutting. So this one is a very simple simple project. We have a Fanic robot, a spindle, and a side panel. The side panel in this case mimic a side panel from a bus. Anyway, another customer. Very watered down version of the actual project we were attacking, but still. So the goal here will be to be able to just first contour that part here. So let's say that part comes out from a press, a plastic molding system. It can be potentially in carbon fiber, and you need to cut the excess material around the holes and around inside of the holes and outside of the part. So I'm going to show you that when we're talking about the actual robot machining project. But let's say that we have the NC file here in the in the folder, and we have robot cutting contour.apt. So like I said, in this case it's an apt, nci .g code would have also worked. If I take it, drag and drop it to RoboDK, it will automatically create a robot machining project. So I could have done the same by utilities, robot machining project, and then select NC file and just go select the right file, or this will also work. So what does it do exactly? It will create your robot machining project. In this case, you can go like usual and make sure that your orientation makes sense for you. You can go update, and then you can go simulate. And then if I use a slider, now I have 2 passes, and it's voluntary, so I have 1 cutting passes and 1 finishing pass. And I'm doing 2 times around the actual part, and then the last window. So the order I did not decide, that was decided by the CAM package. So the cool thing is that if someone already is already familiar with the CAM package, he should be able to do that kind of path like in a matter of minutes. Just send it to RoboDK, and like I just showed you right now, from RoboDK it will be translated to a robot path. And you have access obviously to the same exact feature as usual, so be able to avoid singularities, joint limits, decide the starting point, minimum tool orientation change versus tool orientation follows path versus robot holds object. All of those are accessible and here. So I just want to show you what's inside the apt file. So I'm going to open VS Codium, just a text editor that comes with RoboDK. We'll discuss that later. And I can open the apt file. So apt file aren't very easy to look at, let's say from a human eye. But yeah, you have a bunch of go-to, selecting a cutter, we'll talk about that, but it's a bunch of go-to to certain X, Y, Z position. And then if there's any, so they have some move arc, so if you need to do an arc or section of a circle, a bunch of go-to. It will give you the feed rate, so the feed rate is the actual speed you wanna move forward. So it's in this case it's in millimeter per minute. If the feed rate has to change, it will do so. It will go to rapid motion in between the sections of the cutting, and then go back. If the spindle needs to spin, it will give you a spindle speed with a number which represents the number of RPM, and in this case it's rotating clockwise. So this is all the information you have in a NC file that will be transmitted to RoboDK, and RoboDK will interpret. Anyway, it will look at those information, translate that to something that is usable. It will take those information, bring it to RoboDK, and then from RoboDK translate that to something that is usable for your robot controller. So RoboDK here is kind of the middleman that do the translation first, but there is already some post-processor in some CAM software that can do the post-processing, let's say directly for KUKA, Fanuc, or other robot brand. But the thing that they don't do that we do is making sure that there is no singularities, joint limits, collision, and that you're able to adapt yourself to different position, if I can say, from from a robot perspective. So it's not a simple brainless translation like this is a go-to to blah blah blah, let's just create a move L to this value here. Yes, this is what we do if this is possible, but if it's not possible, this is where RoboDK comes in with our algorithm to avoid singularity, joint limits, and other issues that you can face. I also have another small example for here 11E additive manufacturing. So we have a Nachi robot and an extruder, a simple frame here, NC file. I'm gonna drag and drop this extruder here. Okay, yeah, I was wondering why it wasn't coming in. Just took a bit of time to get in. So this is just a simple RoboDK logo I have here. And if I bring in the G code here for the 3D printing, okay, so this is a bit of a, not an issue, but here this is just the part I imported, and this is where it was positioned in my slicer. I'm gonna explain you that in the video where we talk about 3D printing. But you can see here is the same exact pattern. It was sliced by a slicer. In this case I used the included slicer with Fusion, but any slicer would do the trick. So you can see we even have the skirt here at the bottom. We have our layer. We have all the transition between the different sections of the 3D print. And if I was to come here, click update, this one is way bigger. As you can see, there's almost 1,000,000 points to reach. So that's quite a bit. So even if it's a, so you will see we have utilities, robot 3D printing project. What's going on here? I'm just gonna go ahead and make that down here, set current, update. That should work like that. You will see if we click utilities, I can't right now because this is running. If we click utilities, we have 3D printing project. I'm going to explain you what 3D printing project does exactly. But if you just come in with a G code that was generated elsewhere and drag and drop it to RoboDK, it will create a robot machining project. But at the end of the day, it's the same exact thing, same exact way of working with that. So it's updating the pad. This is a good sign. Okay, and now if we simulate, and I can just press play here. Yeah, we'll talk about certain, like, kind of, not difficulty, but like, as it's a 3D printing project, there's a lot of points. So even if you're trying to use the fast simulation speed, it won't work. You kind of need to use, it will work, but it will stop at each point. So even if you're trying to go at 100 times the speed of the actual simulation, it won't go very fast here because it will stop at each point. On the contrary, if you use the slider here, it's just running all the joints value one after the other, so it doesn't add a certain, let's say, it will give you like one every 4 joints or something like that. So it doesn't matter if there's a lot of points or not, it will always go as fast as possible. So if we were to go to move a bit closer and look at it, I can potentially remove the normal so that we can just have the pad here. So I'm doing like basic 3D printing, and I could just also simulate this, just simulate here. Because what I mean is, even if I press space, which should give me like fast simulation speed, as it's stopping at each point, it's not going very fast because there's a lot of points, especially in the corners. There's a lot of points. If I was to show the normals, you can see here, like there's 1 point here, there's 1 point here, but here in the curve, there's a lot of points. So we'll discuss that in the 3D printing part, but that can be a good thing to potentially slow down on the points if you can have some kind of tolerance from your 3D printer, because robots aren't as good as a 3D printer to handle a high density of point. So yeah, that's another subject. So that concludes how to import paths to RoboDK. So the four options that we saw were extracting directly from the 3D model, CSV file, and importation, CAD plugin, and in this case, NC file. So yep, that's it.